Okay, ladies and gents, today we're going to do another electrolysis, only we are going to just be using copper and copper sulfate for today. Because all we want to do is we want to transfer copper from one electrode to another electrode and be able to trace the mass that's changing by being able to observe how many, or the amperage that's coming through it. Because the work that we've been doing in class so far has been taking a time and an amperage and turning it into coulombs of charge, or using Faraday's constant, amount of electrons that have been transferred. So there's a lot of stuff that we can tell by being able to monitor amperage and time inside of a reaction. So as you are taking data today, I urge you to kind of find the midpoints of all the amperage data, because it's not going to stay 100% consistent the whole way through. But what you need to do is you need to trace the amperage and keep track of it as well as you can. Okay? So that you can actually, as accurately as possible, talk about the amount of coulombs of charge that have transferred so that you can see if you can, well, eventually come up with Avogadro's number. So today, we just have a real simple setup. We have the same volt and amperage reader and giver that we had last time, the same box that we did last time. We have our scale so that we can trace masses. I've got some acetone to do a quick rinse so that we can get rid of the water that's there without, scrubbing and rinsing it and then having to let it dry for an excessive amount of time. But other than that, that's pretty much it. So here is going to be my cathode. I'm going to hook this up to the black lead today. So I'm going to zero the scale and then add Mr. Cathode. And today, Mr. Cathode is going to be starting at 19.6593. Okay, and I'm going to put him on this side and anchor him. Okay, and now here's Mr. Anode. And Mr. Anode today is going to start off, I'm going to connect this one to the red lead. And the anode today is going to start off at 19.6205 grams. 19.6205 grams. Okay, I'm going to put the anode over here. The reason I'm taping them down is so that they don't accidentally shift during electrolysis and touch one another, because that would short out pretty much everything here. So I'm going to add the copper sulfate now. Just want to cover up the bottoms of those electrodes, put about 150 mils inside. And now I'm going to hook up the black and the red leads. Okay, so now we are ready to roll. So timing is critical. So as soon as I turn on the power box, that's when your time begins. So you should know where on this video the time marker is for start and where the time marker is for end. We're going to attempt to be somewhere between 3 to 5 minutes so that we can have a good flow of electrons before we stop it. Then we'll rinse, take our final masses, and be done, because everything else now is calculation in your hands. So here we go. Ready? And on. We are only running 7 volts through this system. We don't want to do much more than that, because then it generates too much heat, and the more heat that's in the system, it just starts amplifying higher and higher and higher in terms of amps. So right now we're staying pretty consistent at 1.30 amps. I'm going to try to keep that as consistent as possible by maybe messing around a little bit with the voltage, just to try to keep it at 1.3 for this whole process. Okay. It's not the voltage that you need to worry about, it's the amperage. Okay, we've been running our system about 2 minutes. All right, I'm going to kick this back down because I don't want it to go too crazy on us. I'm just going to try to keep it around 1.1. I'm getting closer to the time when we're going to shut off the system. We're about 50 seconds away. That'll be about a good 4 minutes of the system running. Okay, about 10 more seconds, then we're going to turn it off. All right. So now we've turned off our system. All I'm going to do is disconnect it. We're going to rinse the different cathode nanodes, and then we're going to take the final mass. But while I'm doing that, what I would recommend is finding average amperage for that whole time. And it's going to be a little bit tricky, a little bit difficult, but I believe in your mathematical abilities. I believe in your playing with video to be able to find that average amperage. Because if you find the average amperage, you only have to do the calculation once with that average amperage. Okay? So I'm just trying to get this electrode nice and dry, and it is. So now we're going to take the mass of the cathode. Final mass of cathode is 19.7403. 19.7403. And now let's take the mass of the anode. Going to do a quick rinse of that one too, just so that it dries. Okay. Okay, you can see that it is now dry. Little bit, very, very tiny specks of some copper sulfate crystals on there that didn't rinse away with it. So if you're looking for error inside the slab as to why you're not the exact numbers you should be, I would look to the small, tiny copper sulfate crystals that are on each of these electrodes. The anode final mass is 19.5681. 19.5681. Okay. You have the initial masses, you have the final masses, you have an average amperage that you're aiming for. You can now calculate coulombs. You guys have everything that you need to be able to tell me the amount of electrons that is transferred and compare that to Avogadro's number. So, see ya.